All right, I'm glad to see some people are still here today, even though today is one day before Thanksgiving. I have started the streaming on the other side too, so YouTube should be streaming now. I'm just double checking. Yep, that's streaming right now. Cool. All right, so we'll find out how many people are going to show up today, even though I am going to record the lecture. All right, we got about 2 minutes and a half to go. I'm glad to see there are at least 4 people showing up on Discord. And I got a DM, and that's for a different class. Okay, never mind. So we're good to go here for this class. I have to say that this is before class starts. So I'm kind of surprised to learn that in my other class, in CISP440, I gave the class, some ungraded assignment, just so that people can keep their engines warm, so to speak, over the break. And then some people complained about it, even though it's not even graded. It doesn't count to the final grade, and someone, basically just, said it, I guess, with some defiance and say, "I'm not going to do this. There's absolutely no way I'm going to do the ungraded assignment." And I was just thinking, the assignment is not really for my benefit. It is really for the benefit of the entire class, so that people can, basically go back to class on next Tuesday, and not to lose track of what we have already talked about at this point. Because on the Tuesday Thursday class, Thursday is off, so basically it'll be another week before the class meets again. So I was just kind of surprised by people who not only say that I may not have time to do the ungraded assignment, but basically just be defiant about it. It's like, that's just kind of strange. It's strange to me because this is not high school. It's not like it is required that people have to be in a particular class or to take a particular major. So if this is not something that they want to do, I mean, it's just kind of weird. It's just kind of weird. I see. I guess I'm not really understanding that mentality. Basically it's like, why, and these are not even graded assignment. It's just suggested activity for people to do, and I'm simply saying, hey, if you do this, it might help you understand the material better, and maybe you'll get a better score in the final exam. So anyway, I'm not gonna spend too much time to think about it. It's just kind of noteworthy from the perspective of, I just cannot understand. All right, so getting back to this class, we have let's see, we got 5 people showing up, and that's perfectly okay with me. All right, so what we'll do today is actually going back, because last time I was kind of excited to talk about if 0 people shows up, I will still be teaching the class to basically cyberspace. Um, I had taught classes before, face-to-face classes, where there were like 4 students. This is back when computer science classes were had very very low enrollment because of the dot-com bust, and that's probably before some of you were even born. So there were like 4 students in class, like 4 actual students enrolled in class, and they did not respond to questions at all. It is as if they were not even there. They just gave me this kind of blank, half smiling Mona Lisa face the entire time. It's like, yeah, I'm pretty sure you guys are not understanding this concept. Why don't you ask me? Why don't you just tell me that we need more time? And they just gave me this Mona Lisa face the entire time. It was just weird. It's almost like I was at a museum looking at paintings of people, except it's kind of 3D-ish. Oh, Canvas has a redesign. Yeah, so instead of spending time to actually fix bugs in the quizzes, they decide, why don't we just spend some more time to play with CSS and change the looks of Canvas? That's also a mentality that I really absolutely cannot understand. Yep. I gave them the code to fix it. It's like I'm pretty sure this is what the problem is. Because if in a calculated answer, if the actual answer is a 0, Canvas will give you a warning and say that you did not put in an answer. So that's a pretty typical programming error in a scripting language, because the value of 0 can be interpreted as false. So if someone is really lazy and just kind of coerce a string in a Boolean context, then an empty string, it's going to be false, but so is the actual answer of 0. It will also be interpreted as false. Okay, so I already knew exactly why the code is doing it, and I sent my suggestion and bug report to Canvas, and to date, like 3 years later, the bug is still there. So look new, so it is new. So anyway, all right. So I guess we'll kind of be a little bit kind of light today in terms of the discussion of the topics, just because I know people who are showing up still kind of want to be done a little bit earlier, and so you can move on to other stuff. Yeah, Wade, that is, yeah, that's really has no excuse. Before Canvas, I used an open source program called Moodle to teach my classes, and Moodle is open sourced. And the way Moodle works, like almost all open source projects, is you have the source code, okay? You have the power, okay? Yes, I did quote from He-Man. So you have the power, okay? You don't even need the sword, you have the source code, even better than the sword. And so with Moodle, things get fixed like really, really quickly. Sometimes people would put in the fix, and just have a disclaimer to say that, well, I haven't really tested this for all the possible cases, but it seems to work. Okay, so you can kind of choose and go like, yeah, that seems like the right fix, put it in. And other times I look at the source code and go like, yeah, I think I know how to fix this. So I would just go ahead and plug the plug the bugs. So back in those days, it's easier to get problems fixed, just because I can read the source code, and most of the time I can figure it out. And Canvas being a for-profit type of product, the company is actually called Instructure. It is not exactly excusable that they know a bug and not fix it for such a long time. All right, so what we'll do today is to look into Prolog again, and I'm not going to start with the boring stuff here first. Okay, I'm going to start with another example with Prolog. Yeah, it's a prioritization. The reason why capitalism doesn't work in this case has to do with what is the reward. In terms of if I put in this much time into this, how much do I get? And if I put in this much time into that, how much do I get? And just like Microsoft has a lot of bugs that they never bother to fix. It's because it's not the return is too low. I mean, their terminal emulator, has always been incorrect to interpret some of the VT100 escape sequences. But because there are not enough people to really use the escape sequences inside the terminal in Windows, so they never really bother to fix it. It's like, well, there's 0.5% of our users that might touch that, occasionally, and they just decide, nah, not worth it to fix it. All right, so we're gonna do this example today. It is actually in the module too, so this one does kind of go back to the module, so we can go back and forth between the module and the program. So once again, we have a bunch of facts. Okay, so a fact is really a special kind of rule that makes use of specific items. We call these atoms. And the collection, the set of all atoms, is actually quote unquote called the universe. Okay, that's actually a technical term. No, I'm not kidding. That is actually a technical term. The universe is the set of all things, inside a predicate calculus system. So all of these are items. Anything that starts with a lowercase is automatically an atom in Prolog. So they're basically more like consts in C and C++ programming. So these three facts are basically the Prolog way to state that Luke Skywalker is a Jedi, Obi-Wan Kenobi is a Jedi, and then Yoda is a Jedi. If someone is bothered by my reference of using Star Wars, characters, because that's not something that you are used to, just let me know, and I can probably use some other examples. But without any objection, I'm going to continue to use this example, just because it's already in the notes, okay? And it's kind of fun for people who do follow the Star Wars story arc. So I'm just going to pause here and see if anyone want me to change and not use the Star Wars context. All right, so in Prolog, there's no way to independently define a variable. You cannot declare a variable. Basically anything that is uppercase is a variable. So right here we have two things. We have the name of a rule, like this. This is the name of the predicate, which is a rule. And then we have the name of an item, of an atom in this case, which is Luke Skywalker. So later on we will specify some actual rules, but when you specify rules which are general, then you have to start to use variables, because that's kind of the main difference between predicate calculus as opposed to propositional logic. Propositional logic can specify a lot of stuff. We can actually reason with propositional logic, but the one thing that it cannot do is quantification. In other words, it cannot say, oh, for all blah blah blah, this implies that. There's no quantification that you can actually express using propositional logic. But in predicate calculus, which is what Prolog is based on, you can indeed specify quantification. But right now we don't have any quantification, because right now we are stating the basic facts, which are kind of equivalent to things that you put into the iota set, but it's not exactly the same thing either. So a predicate itself is actually a pretty simple concept. From the perspective of programming, a predicate is a function that returns a boolean. That's about it. Okay, so you basically specify some parameters, and then the function just has to return a boolean as a result. That's basically what a predicate is. So which means you kind of need the concept of a parameter, which is a very special kind of variable, because every time you evaluate a predicate, the parameter can be bound to different values when you're trying to evaluate the predicate. So right now, with only these three items, I can ask some questions. Not necessarily a very smart kind of question, but I can ask some questions. Okay, this is not. I cannot answer the phone, but I can. Okay, I do ask for your. I do apologize for this, because this is from my daughter. I'm gonna have to tell her to call mom instead. All right, there we go. All right, so a predicate is nothing more than a function that returns a Boolean uh, return value. So you just give it a bunch of stuff, it will evaluate something, and it will tell you either it's true or false. So um, yeah, so right here, we can already send a query in. How is a Jedi defined? That's how we define it. This is the entire prologue program. The first part here is really just to set up some boundaries so that when we evaluate something, it doesn't take up like eternity, and also we set up a certain stack space so that we don't it won't take too long to exhaust the entire stack. So this part here is really just for the interpreter itself to configure things. Yeah, so we just determine what value will make is a Jedi true. Exactly. Because remember what we mentioned, what I mentioned last time, because this really is the same thing as only if true. In other words, it's read backwards. This is the true part here is the is actually the left hand side of an implication, and this here is kind of like the implication, but it's backwards. And then this part here is actually the right hand side of an implication. This part here is actually the right hand side of an implication. So it's read backwards. But the other way to read this is Luke Skywalker is a Jedi only if true. Well, only if true is true. Actually, that's basically what it's saying. So in the end, all it really is saying is yes, this is a fact. Just accept it. So that's kind of how we define is a Jedi. So Jonathan is correct. We are just going to specify what values, what atoms are going to make is a Jedi true. Okay. All right. Is force sensitive. So is force sensitive sounds like another predicate because it sounds like it has a Boolean result. So you can specify who is force sensitive. 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 That's what that's what in the text channel. Um yeah. All right. So even with this, okay, I can already ask is a Jedi, and I can specify some atoms that are not even introduced in the program. So I can ask Darth Sidious, and we have to put a control return, and it returns false because it is not mentioned here. So any atom that is not mentioned by a fact that is a Jedi is automatically not a Jedi. Control return means that's just what I need to press on the keyboard in order to evaluate a query. So if I were to change this to Luke Skywalker and then press Control Enter, then it returns a value of true because yes, we did specify quite clearly that Luke Skywalker is a Jedi. So it's control return. The return key and the enter key are basically the same thing. You just have to press the control key first and then press the enter key. That's all. All right, so now we can introduce some additional concepts. So now we can also identify the lightsabers, right? So in Star Wars, I'm not aware that the lightsabers were actually named. So if you know that the the lightsabers were actually they have names, let me know because I would like to know how those lightsabers were named. But since I'm not aware, so I'm just gonna have certain made up names for the lightsabers. So right here we have a lightsaber that is called Anakin Blue. I believe that may be one of the first lightsabers that Anakin made. So we'll go ahead and specify that in. Oh, okay. I use the tab key, but it's actually one of the tabs in the browser. Okay, so is a lightsaber, and we'll say Anakin Blue So this is how we basically say, oh, this is, this particular atom here, Anakin blue is a lightsaber. And we got two people typing, and I'm gonna wait until I see the questions, and then we'll address the questions before moving on. So we're gonna take a kind of relaxed pace today, just because well, actually more people showed up after. Yeah, so we do get a pretty healthy about 10 people showing up. Um, correct. So what you can do is to say, a Force user can be a Jedi. So we'll get back to that one. And how many people still are still enrolled in this class? I believe we have about 18, close to 20 people. So only half the class are actually here in the Discord uh, voice channel. How would we differentiate between Anakin Blue and Luke Skywalker? That's basically what this predicate is. Okay, so this particular predicate here is a lightsaber, is here so that we can associate certain things with the atom, called Anakin Blue. And is a Jedi is another kind of predicate that will basically qualify certain atoms in the universe. Yeah, so it's kind of weird, right? Because we now think in object-oriented way, where the method to confirm what that thing is a method of the object itself. This is not object-oriented. This is actually quite the opposite, right? This is atom-oriented. So you basically create a bunch of atoms, you create a bunch of elements in the set of what we call the universe, and then those atoms by default have no meanings whatsoever. And then you have to use these facts to basically establish what these things are and also how they relate eventually. All right. So Jonathan typed in correct. So unless you have an object that is both, right? Unless you have a sentient lightsaber that is cybernetic, and it can it can be a Jedi by itself because it's an automated lightsaber. Then you can potentially apply is a Jedi and also is a lightsaber to exactly the same atom. George Lucas did not explicitly say that that cannot happen. All right, so Amon said, so to create and define more general rules with variables. Okay, I can't see the entire text because I need to scroll it a little bit here. Okay, so to create and define more general rules with variables, we must have certain other rules to fall back on as a foundation. That yes, so these are the foundations. These are the facts. That do not need any other rules to confirm. Okay, so these are basically kind of like the axioms, but they're not axioms in the sense that they are not specifying a pattern. They are just, for the lack of a better word, ground rules or ground facts. Okay, they are just okay. This is what it is. Okay, and it doesn't depend on any rules whatsoever. So I heard somebody mention something about it's a Force user, right? So in that case, we can say is a Sith, and we can now have all the Siths here. Okay, Darth Vader is certainly one, and so on. But now we can say is a Force user X only if is a Jedi X. So this is one very simple rule. Okay, all it's saying is, hey, if X is a Jedi, then X is a Force user. So if I now start to inquire and ask who is a Force user, or I can specify the person or the atom, and then just want the confirmation one way or another. Now we can say is a Force user, and I can say Yoda, Yada, no, Yoda. Control Enter. Then we'll confirm that yes, okay? But right now, if I were to plug in Darth Vader, it would not be able to answer true because I do not have the alternative specified yet. Jonathan is correct. It's a Jedi. X implies it's a Force user X. All right. But I can specify alternatives. So there are two ways to specify an alternative. One way to specify an alternative is simply to use a second rule. So from this perspective, it is kind of like it is a little bit like overloading, but it's not exactly overloading. It's basically if you fail the first rule, then you will try the second rule. So now we can say is a Sith X. So now we are specifying that there are two ways for X to be a Force user. X can be a Jedi, or X can be a Sith. So with that extra rule here, when I ask the same query and then press Control Enter, now it returns a value of true. All right. Yeah, it's kind of like an OR statement. You can also combine the two using a semicolon. So if I were to join these two lines with a semicolon between the predicate, that would also be understood as a OR. Why did you use Y? I did not use Y. I used X then Y. Oh, that's a typo. Sorry about that. That's a typo. That's my typo mistake. And that's why it complained. Okay, I missed that part. All right, so now it does come back and specify, the answer is true without complaining singleton variables. Okay, thank you. Thank you, Armand, for noticing that I mistyped, in the specification of the rule. All right, so remember earlier I said, this has to do with quantification. So where's the quantification? Are we talking about there exists, or are we talking about for all? So as it turns out, if a name is mentioned on the left-hand side of a rule, which is basically the right-hand side of a conditional statement, if it appears on this part, then it is a universally quantified variable. So in this case, okay, let me just focus on line 16. So on line 16, it is the same thing as saying for all X in the entire universe, if X is a Jedi, then X is a Force user. That's basically what this entire rule is trying to say, because the default is it is a universal quantification. So I can now say this is a for all X. X is a Jedi, implies X is a Force user. That doesn't look good, does it? Force user. There we go. Looks better this way. Just so that there's no misunderstanding what FU means. Exactly. So Armand is correct. Well, okay. In this case, yes, I'm using it kind of like a filter. But every single rule is an implication, and the implication is read backwards. So it's always the right-hand side implies the left-hand side. Yep. All right. So I was asking if we can restrict X. In what way? This is a requirement, right? So in order for is a Force user to be true, we want to confirm that X is a Jedi. So it is a restriction of sorts in this case. All right, cool. All right, cool. All right, so now we have looked at the use of just facts. We have now looked at simple rules, okay, and we now learn that there are alternative rules, okay. So there are more than one ways to qualify whether someone is a Force user or not, because we can say is a Jedi, or you can say is a Sith, okay. So both of these can qualify someone as a Force user. So if a person isn't a Jedi, they can still be a Force user, yes. So you can actually do something like this: is a Force user, and then you can specifically name a specific atom who may not be a Jedi nor a Sith, but nonetheless is a Force user. So give me an example. Okay, with all the movies, name one character who is a Force user but is never officially a Jedi nor a Sith. So we can just kind of plug it in here to establish that there's no restriction to say that you cannot actually use a fact when the same predicate can also be specified by a rule. That monk from Rogue One. Okay, so we'll say Rogue One monk. How about that? So yeah, so this is perfectly okay. So now that we have that particular fact, we can now inquire who is a Force user. So when you're trying to find out all the Force users that you can confirm in this particular universe, is that okay. All right, we can copy and paste it. And I don't think it can handle the non. There we go. So when we now inquire who is a Force user, then it will give us this person, and then it will say, and then it will find Luke Skywalker, it will find Obi-Wan Kenobi, and also Yoda, and also Darth Vader. So this gives you a lot of flexibility because now you can say, hey, I know for certain that these specific atoms, are Force users, but at the same time, I also know that if somebody is a Jedi, I don't need to have duplicate items, right? In a way, this is like inheritance. It's kind of like inheritance. So it's a Force user is a subclass, and then is a Jedi is actually kind of like a superclass, and is a Sith is also a superclass. So we have, it's not exactly multiple inheritance because you only need one or the other to confirm that something is a Force user. So it's kind of like that. I know, I'm mixing up the concepts between entirely different programming paradigms, but sometimes it's kind of interesting to see, how certain things are parallel with each other when when it's applicable. All right, can there be an if and only if so that we can define is a Force user if and only if is a Jedi? That is a good question. Hmm. Well, the other way you can do this is simply to say is a Jedi only if it's a Force user. Um, but then it will, but then these atoms will bypass that specific rule, and it can lead to a circular reasoning kind of thing. So let me think about that a little bit. The if and only if thing. There's only one way for someone to be a Force user. And the other way, the opposite way is the difficult part. Okay, if we can confirm someone is a Force user, we also need to say that that person is also a Jedi. So let me think about that a little bit of how to specify if and only if. So it's kind of like two people going. A is asking what is this thing, and then B is asking, well, what does it do? Not exactly. If you're referring to the if and only if, it's not exactly like that. All right, so I'm going to put some thoughts into the if and only if thing, but right now I'm going to show you an example of relating things. So now we want to basically associate who owns which lightsaber. Um, and Luke Skywalker eventually inherited the first lightsaber that Anakin made. I believe that was from episode 4. So now we can specify ownership. Okay, so we can say owns, and basically it's just a different way of arranging words in a sentence. The verb is basically the first item. So we are turning something that is infix into a prefix notation. So now we can say Luke Skywalker, and then the object that he owns is Anakin Blue. There we go. So now we can express relations. So, and the relation is really kind of arbitrary because when we talk about relations, when we talk as in relation, you can only relate two things, right? Because we are talking about the Cartesian product of x and x, okay, and R as a relation has to be a subset of that. But when we are specifying these facts in using Prolog, there's no restriction whatsoever. Okay, you can have a bunch of things and you just say, okay, this is a fact. It is a fact that this predicate is true when these specific atoms are the arguments. So it's much more general compared to the relations that we have already talked about in this class. Okay, so now we can say, what about a proper Jedi, right? So someone can be a Jedi, but somehow has lost the lightsaber, misplaced the lightsaber. I would say that person may not be a proper, Jedi. So now, in order to be a proper Jedi, someone has to be a Jedi first, and then that person will also need to own a lightsaber. Okay, so we can now qualify all that stuff, and we can say is a proper Jedi X. Now this part here is interesting, so I'm gonna point out which part is interesting here. The first one is not. Okay, first one is to say, well, in order for someone to be a proper Jedi, that person first has to be a Jedi. Okay, that's not surprising, right? Just like the implication style for defining. Not exactly sure what that means. So if Wade can expand or can elaborate a little bit, that would be helpful. Okay.
I just mean that the implications are read backwards,
Oh
right?
yes,
So
yeah,
like you define the properties of a thing, and that's how you define the thing.
yep, exactly.
Yeah.
Yep. So remember this symbol here, you can read this symbol as only if. All right. So when you use only if, it is actually kind of like if then, except it's opposite in the opposite direction. So that's only if. And then this comma here is significant. A comma, when you use a comma in a rule, it's specifying conjunction. Okay. I do not know why your Prolog does not use anything that resembles a conjunction, but it decides to use a comma to means conjunction or and a disjunction or is specified by a semicolon. So now we can specify an additional predicate that has to be true. So now we can say, we need X to own a Y, and then we need to make sure that Y is a lightsaber. Is a lightsaber. This user interface does not have the ability to autocomplete, which is kind of kind of something that I wish it has, but it does not. So now we have a rule that has two variables. We have variable x and variable y. Yeah, we can use variable y and z as well, but this time I'm going to explain the differences between variable x and variable y. Now variable x is not the same as variable y because variable x is also mentioned on the left hand side. So if it's mentioned on the left hand side, which is where I just did the highlight here, it is universally quantified. X is universally quantified. So what about y then? Because y does not appear on the left hand side. Y is something that we introduced on the right hand side of the rule. So as it turns out, y is existentially quantified. So the entire thing, okay, so let me just kind of use a new line to specify how we should read this. So if in Prolog a percent symbol starts a line of comment. So if we want to read this, it is now saying for all x and then in parentheses. So I'm gonna do this in a kind of structured way. So now we can now say is a Jedi if x, okay, x is a Jedi. Okay, that part is easy. And So now we have to introduce the concept of y, and y is existentially quantified. So now we say, there exists y such that, okay, so I'm using another level of parentheses here. So now we can specify, how we are using y in conjunction with x. So now we can say, x owns y, and y is a lightsaber, and then we specify the it then x is a proper Jedi. There we go. Yeah, so own does have two parameters, but the special thing about y is it is not on the left hand side of the rule. And any variable that only appears on the right hand side but not on the left hand side are existentially quantified. So if you read this entire thing, you're kind of changing back from the prefix notation to the infix notation, because we are much more familiar when we're dealing with an infix notation. So the whole thing is kind of like saying for all x such that x is a Jedi, and there exists a y such that x owns y and y is a lightsaber, then x is a proper Jedi. That's basically what it's saying. So the other way to say this in in a normal casual colloquial type of English is to say, in order to be a proper Jedi, one must be a Jedi and owns at least one lightsaber. That is how you would read it, if you were to explain this to someone who is not taking this class. So are we doing okay so far? All of this discussion is about the rule that I specified on line 26. So do we have any questions about that? I'll give you guys some time to kind of think about it. It's also discussed in the module too, but in a much more boring way.
Real quick.
Yeah, yeah.
So with the is a proper Jedi, just to make sure that I'm on the right track, why hasn't been defined as an object, right? It's a function header name, right?
Why
It's like right?
why is a variable? It's just not universally quantified. It is existentially quantified. In
Okay.
other words,
So it has permanence.
it we only have to find at least one thing be that can bind to variable y to make owns and is a lightsaber true,
Uh-huh.
instead of saying we have to find every single y that can make owns and is a lightsaber true.
Okay. Yeah, thank you.
Sure. All right, so with this in mind, we're going to go back to our query screen here, and then we'll ask who is a proper Jedi? Is a proper Jedi? And we already know what the answer is, because Luke Skywalker in this particular universe, at least based on how we have documented the atoms, would be the only person who can qualify as a proper Jedi. So when we click next, it's just going to return false. There we go. The reason why it returns false is because we can make part of the right hand side true, but we cannot make the rest of it true. In other words, other than Luke Skywalker, we have some other Jedi's, right? So we have Yoda as a Jedi, and we also have Obi-Wan Kenobi also as a Jedi. So the way Prologue works is it automatically does what we call a retraction, and then it would branch out again. So the way it works is when we first ask, okay, who is a proper Jedi, it looks at the only rule in this case and say, okay, we need to find out, what this X can be. So it would go into the definition of the rule, and the first thing it asks is, okay, so can someone give me a Jedi? Okay, so Luke Skywalker is indeed a Jedi, and then after satisfying the first um, part of the conjunction, it's going to go to the second part of the conjunction and ask, can we make this true as well? Okay. Now remember, at this point, X is already bound to the atom of Luke Skywalker. So we have a constraint and say we're not just looking for any kind of ownership. We're looking for an ownership where the first item of the tuple is Luke Skywalker. In this case, we have only one own relation, which is between Luke Skywalker and Anakin Blue. So that will basically be the one that will make this particular item in the conjunction true. So now we have bound both X and Y, because X is now bound to Luke Skywalker. That was done in the first part of the conjunction. But we, at the same time, now we have found that, hey, if Y is Anakin Blue, then we can make the owns, X, Y also true. Then it moves on to the third item of the conjunction. And at this point, X and Y are both bound to specific values already. So the Prolog engine really doesn't have any flexibility. All it can do is to confirm or not, whether Y is a lightsaber or not. And if Y is not a lightsaber, then it will come back as false. Then it will try to find other things that Luke Skywalker owns, and then see if those things are lightsabers or not. So it will automatically go back and forth to try to satisfy all of the constraints. Now, if the constraints cannot be all satisfied, then it will come back as a false. In this case, X cannot be a proper Jedi because at least one of these three constraints cannot be met. So that's kind of the internal mechanism of Prolog. It does all of these kind of. It's the way it is doing it is a depth first search kind of mechanism. So, but it does automatically do the backtracking, so that it can explore a new path to see if there's another path to make the entire conjunction true. Am I doing okay so far? I mean, does everybody understand the general idea of what is depth first search? Because I can explain that too. It's a very important concept, even though it's not directly, specified in this class, but nonetheless, it is a very important concept. Okay, I can explain that. All right, so depth first search is okay. Let me try to think of an example first. The best way to do it is to use a picture. So I'm gonna have to I'm gonna turn off my camera because when I use my tablet, I kind of have to lean a lot more forward, and all you can see would be the pores on my face, and that would not be a good sight. So I'm gonna turn that off. There we go. All right, so now I'm gonna kind of sidetrack a little bit to talk about what is depth first search. And I need Zernal, which is all the way here, or not. Maybe under Office. There we go. Zernal++. All right, so oh, I know, because you guys must have taken CISP430 already, so we can use trees. Okay, trees are great to illustrate the various ways of quote-unquote searching, especially when we want to talk about breadth first search versus depth first search. Okay, so we're going to use a tree in this case. So we're going to have a tree. We'll have node A here, B over here, C over here, and then we have D, and we have E, F, and then we have G, H. Okay, there we go. So now we have a tree. We can have one more for G. We can have I over here. All right, so we have a tree here, and let me go back to make sure I can still see the Discord text channels, because my screen is just not big enough to show everything at the same time. So it's just a constant thing that I have to move things around to see what we are talking about here. So we have 4 leaves. Okay, we have 4 leaves. D is a leaf, F is a leaf, I is a leaf, and then H is also a leaf. So basically, a leaf in a tree is one that does not have a any quote unquote descendants. So that applies to D, F, I, and H. So when we're doing a breadth first search, we are basically going level by level. So that so a breadth first search, okay, so BFS. So breadth first search is going to have A first, okay, and then between B and C, we can go do it either way, okay, so there's no ordering between B and C, and then it would go to the next level, and that would be D, E, G, F, D, E, G, H. So between D, E, G, H, it can be any order, okay, between B and C, it can be any order, but A has to precede B and C. And then B and C, as a group, has to precede D, E, G, H. And then finally, we have F and I. Those would be the last one. So this is the ordering of a breadth first search. It is basically just trying to draw concentric circles from A and then see, okay, who is the closest to A, B, and C. And then we ask, okay, if we expand that circle one more time, what would be the next group of nodes? Then it will be D, E, G, H, and then if we expand that circle one more time, then it will be F and I. Yes, exactly. It's level by level. That's breadth first search, which is actually what Dijkstra's algorithm does. Okay, if you think about Dijkstra's algorithm, that's what it's doing. Okay, if you want Dijkstra's algorithm to do exactly what we see here, all you have to do is to assign the same distance between all the edges, and then turn all of these into edges. Then Dijkstra's algorithm would basically, oh, I take it back. I take it back because with Dijkstra's algorithm, it is starting with a destination. So all we have to do is to kind of reclassify the problem a little bit here. So all of these arrows kind of goes the other way around, and then A is the destination, and all of the other vertices are non-destination vertices. But I think you get the idea, right? You get the idea that we simply just expand the boundary over a little bit larger and a little bit larger and then a little bit larger. So that would be a breadth first search order. Depth first search is basically to go as deep as we can and then back up and then see if there are any alternatives that we have not explored yet, and then go to the alternative and then go as deep as possible again until we hit a dead end, and then we back up again. So in depth first search, okay, let's make the assumption that we prioritize a left branch and then a right branch. Okay, so because in depth first search, in this case at least, we kind of need to specify which side do we go first when we have both a left child and also a right child. So we're going to say we are prioritizing left side first. Okay, so we'll say left side first. Okay, so with that, I'm trying to see if this. Oh, okay, excellent. There was a little bit of a problem earlier, not for this class, but I wasn't able to type. So in this case, A is the root, so we have to start with A. Then A has two children. It has B and C, but since we go to left side first, then it's going to go to B first. And then B also has two children, which is D and E. Then it will go to the left hand side first, which is D. So now we have gone as deep as possible, everything on the left hand side, and now we have hit a leaf node, which is basically a dead end. So at this point, the algorithm would basically do what we call backtracking. Backtracking simply means, oh, okay, I'm going to go back to the previous node, which is B in this case. So we go back to B, and then we ask, are there any children of B that we have not explored at this point? And we have only explored the left child, so the right child is unexplored. So at this point, we explore the right child of B. But in the depth first search, B usually does not count as being traversed again. Okay, so B is traversed already here. So we go from D and then we to E. And then we ask, from the perspective of E, we ask, do you have any children on the left hand side? E says, yep, we got one, which is F. And then F is a deadline, not a deadline, it's a dead end because F is a leaf node. So at that point, we backtrack back to E, and then we ask, hey E, do you have any other children that we have not explored? E does not have any other children at this point because it doesn't have a right child. So we have now exhausted everything that we can branch out from E. So now we backtrack back to B, and we ask, hey B, do you have any children that is unexplored at this point? But we have just explored both sides of B, both the left and the right child of B are both explored. So now we backtrack to A, and then we ask A, do you have any unexplored children? A says, yep, I have a right child that has not been explored, which is C. And then we now go look at things from the perspective of C and ask basically the same questions, right? Do you have any children? And if so, we're going to go explore the left child first, which is G. And then we ask G, do you have any children? If so, we'll prioritize the left child first. But G doesn't have a left child, okay? Not a problem. And then we ask G again, do you have a right child? And G says, yep, I do have a right child. It is I. And then I is a dead end because it's a leaf node. We backtrack to G, and then G says, okay, I don't have any more children unexplored. Let's go back to C. So we get back to C, and then we ask C, do you have any unexplored children? Well, the left side is now explored, but I do have a right child, H, that is unexplored. So now we get to H, and the H is the very last node, or the last leaf in this case, that we explore because that's kind of the end of the whole thing. So after we explore H, it backtracks back to C and asks C, do you have any additional children? No. And then we backtrack back to A, and then we ask A, do you have any additional children? A says no, and now we are done. So this is the ordering of a depth first search. Basically, we are going as deep as possible, and when we hit a dead end, we back up. So this is automatic. The whole backtracking mechanism is automatic when you are using Prolog. And that is really why Prolog is such an interesting programming language, is because it has built-in backtracking. The mechanism is automatic. So it will basically exhaustively find all possible solutions when you specify a variable in a query. Okay, any questions? This part is a little bit beyond the scope of this class, but I felt since I was trying to explain the mechanism of Prolog, it is kind of important to mention depth first search and backtracking as a mechanism, because this is it's the right context to talk about it. Backtracking itself is not an algorithm. It is more or less just a technique of performing depth first search, because when you hit a dead end, you have to backtrack. You have to basically go back to the previous node, and if that node has no more options, then you backtrack again to another node that is even earlier. I mean, this is a perfect mechanism for deleting a file. If you think about it, okay, recursive deleting a folder can make use of depth first search. Okay, it doesn't make sense to use breadth first search to delete folders, because if you use BFS, breadth first search, to delete folders, then you kind of need some extra memory to kind of keep track of all the intermediate folders when you don't need to. So when you want to nuke a folder, okay, let's just say that this is expressing the hierarchy of folders and files. So A has a subfolder of B and a subfolder of C. B has a file of D and a subfolder of E, and then E has a file of F. So the way we perform the deletion is, when we try to delete A, A says, hey, you cannot delete me because I got stuff, okay? And what stuff do you have? I have a subfolder B and I have a subfolder C. You go like, crap, you cannot delete A. But instead of having to keep track of both B and C, we only have to keep track of B. And then we ask, hey B, can I delete you? B says, nope, because I have stuff too. So B says, what stuff do you have? I have a file D. Fine. I'll delete the file, okay? Because D is just a file, it's not a folder, so we can just delete it. Then we get back to B and go like, hey, you don't have a file D anymore, can I delete you now? B says, no, I have a subfolder. The subfolder is E, and we get to E and we ask, can we delete you? And E says, no, because I have a file, which is F. So we delete F, we go back to the folder E, and E is now an empty folder. So the rule for most file systems is you can delete a folder only if the folder is empty. There's no file contained in the folder. So we can now delete E, and when we backtrack to B, B is now empty because all of its content are deleted at this point. So we can now delete B, and we get back to A, and we say, hey, A, can we delete you now? A says, no, I still have a subfolder C, and so on. I mean, I'm pretty sure I don't need to finish the entire process. You guys get the idea. Is that okay? Okay, excellent. Yeah, so this is it's not exactly a CISP440 concept, but depth first search, backtracking, those are very important and useful mechanisms for searching in a tree. Now, you can apply that to a graph as well, but there are certain caveats when you apply depth first search in the graph. Because in the graph, you can have loops. And the basic depth first search algorithm does not look to see if you are in a loop already. So if you perform depth first search without being able to detect that you have been at a particular node already, then it's just like in a maze. You can basically go in a circle because you're not remembering that I have been here already. So to perform depth first search, in the case of a graph, which can have a loop, is potentially it requires a little bit more work. Okay, you kind of need to check whether the node that you're on is something that you have been to already in the current branch of the depth first search technique. If so, then you cannot go back there. You basically immediately recognize that, oh, okay, I'm at a dead end, because if I go forward one more time, I'll be going back to a place, a node that I have explored in the current branch of searching. So that's it's interesting, okay, but I'm not going to go too much into how to fix depth first search in the case of a graph or things that can contain a loop. Because one technique to do it is called successive deepening depth first search. So in addition, okay, yes, I guess I just lied because I said I'm not going to talk about it, and here I am talking about it. So the idea is you have a depth limited depth first search. So you basically say, you tell the algorithm and go like, okay, go ahead and do a depth first search, but do not exceed a depth of 3 levels. So even if you have a loop, it's still going to terminate, right? Because there's a rule of no more than 3 levels of depth. Then after that you can go for a depth of 4, depth of 5, depth of 6, and so on. So this way you don't need to have the mechanism of detecting that you have been at a particular vertex already or a particular node already. And even though you have a loop, and you will still be able to process things without having to worry about having to remember whether you have been at a particular node already or not. So that's a successive recursive deepening depth first search. So with each successive attempt, you can deepen the search by 1 or more levels. It's an interesting technique. It sounds pretty useless, but it's actually pretty useful in some contexts. All right, so back to here, finally. All right, so now the question is, what about negation? What if I want to specify negation? So in the module, it talks about a specific example of a negation, and it has to do with, not sure whether it's here or not. I thought I did. Yep, there we go. So now we want to specify Sith Tolerant. So this is negation, this symbol here. Okay, let me highlight in the browser. So backslash plus is a negation. So X is Sith tolerant if you can find a Sith Y and X is not known to disagree with Y. That will make X, Sith tolerant. So let's integrate this into the rules and see if we can find a particular Jedi who is Sith tolerant. Okay, so we copy.
Qui-Gon.
Hmm?
Qui-Gon Jinn. He was in love with Ventress. No, different guy. Sorry.
That's okay. We can set up any rule we want. Okay, so this is our universe still to play with. All right. So first of all, we already have Siths, defined, and let's just say that this is, um, I was thinking about Luke Skywalker, but Luke Skywalker is probably not very tolerant of his dad. Let's see. Okay, so we're going to have to specify some disagree with first, right? So we're going to say disagree with. And we'll specify certain people who disagree with each other. Now, this part is kind of important too because it's order dependent, okay? Because we're specifying tuples, not set. So that means if we want to say Yoda, and Darth Sidious. There we go. So this is only going in one direction. Okay. In other words, what this is stating is Yoda does disagree with Darth Sidious, but not necessarily the other way around. So this is entirely possible. If this is the only thing that we have here, it is entirely possible that Darth Sidious is actually agreeable with Yoda. So Yoda can say, I think what you're doing is bad. I disagree with you. And then Darth Sidious can turn around and say, but I do agree with you that you are doing something that's good and I'm doing something that's bad. I think we have that in agreement. So that's entirely possible. So if you want to express it's a mutual disagreement, you actually have to specify in both directions. So now you have to also say disagree with and with Darth Sidious as the first atom and then Yoda as the second item. So it is not automatically bidirectional. If you want to specify relations, it really kind of goes back to relation because remember in a relation, the set R is a set of two tuples, which means the order does matter. And in this case, the order matters as well. Okay, so now we can specify. Okay, so it's good right now because no one is disagreeing with Darth Vader at this point. So now, if we ask, okay, is Sith tolerant, and then we ask, let's see, Yoda. Okay, so we are asking, is Yoda Sith tolerant? What do you think the answer is going to be? Because the rules we have set up to this point can suggest in either direction until you take into consideration of the quantification. So the question is Yoda considered Sith tolerant based on what we have defined in this in this particular program? So the first thing is we can definitely tell that Yoda is not agreeable with Darth Sidious, and Darth Sidious is a Sith. Okay, did I specify that? No, I have not specified that yet. Okay, so let's go ahead and specify that is a Sith, Darth Sidious. Okay, so now we have that fact also established. So now we can say, hey, so the way we look at this is to look at it from the perspective of prologue. Okay, so we are pretending that we are the computer and we are trying to figure out the answer to this question. So the question is someone Sith tolerant? And the first thing we need to do is to find a Y that is a Sith. So the first Sith that we find is based on the ordering of the facts. So the first Sith that we find in this case is going to be Darth Vader. Okay, so Y is bound to Darth Vader first, and then we are asking, do we have any confirmation that someone is disagreeing with Darth Vader? And we go through the two disagree with rules. One specifies that Yoda is disagreeing with Darth Sidious, but it's not going to work in this case. It won't. It will not make this true because Y is already bound. Because by the time we get to here, Y was already bound to the first Sith in the facts, which is Darth Vader. So that means y is already not a variable anymore. It's not a free variable anymore. X is still a sort of a free variable at this point. So y is already a Darth Vader, and we are asking, who is disagreeing with Darth Vader? Nobody, right? So since no one is disagreeing with Darth Vader, this X can be anything. It can be anything in this entire universe. It can be a lightsaber, and it will still work. You guys are thinking, no way, no way, right? Anakin Blue being a lightsaber is Sith tolerant. Well, let's check it out. So we'll plug in Anakin Blue and Control Enter. Okay. I have a typo somewhere. Sith tolerant. Operator required. Is that the space that it's expecting? It must be. Otherwise. Alright, so let's try that again. Nope, it's still complaining about operator error. Nope. Did I misspell? Sith tolerant. Okay, I don't think I misspelled. Is a Sith, not a misspelled. Disagree with, not a typo. Alright. Nope, it still complains about the same syntax error. Alright, so why is it complaining about a syntax error? Pretty sure this is how we specify negation. I can double check that. Let me double check that. SWI prologue negation. Yep, there we go. \+ if goal cannot be proven. Okay. And that is what I want to specify here.
They're asking in the chat if you for sure capitalized the A when you defined it.
Oh, the A, which is the X here. Now this is the one that I actually copied and pasted from the browser. So it is possible that it is a encoding thing. So I'm just going to retype the whole thing and get rid of the other one. Oh, there we go. Oh, yeah, I really should have turned back onto the camera, because you can see me just kind of leaning back, because it's like, oh, so that's what it is. You can see how the dash is kind of short over here, and and you can see how the dash is really long over here. It's not the same character. Once something is getting through LaTeX, it may look like a dash, but it's not really a dash. All right, I should have known this
Professor,
one.
you spelled tolerant wrong.
Oh, right, yeah. Thank you. There we go. That's a little bit easier to spot compared to the problem that I had, which is a little harder to spot because the dash is actually not the same dash. There we go. Okay, so I think this time it will work. Okay, let's try again. And it says, yes, Anakin Blue is indeed Sith tolerant. Oh, so we might want to limit, right? Yes, we can probably say that um, the lightsaber does not have an disagreement with a Sith, but it doesn't seem to make sense that we need to know whether a lightsaber is Sith tolerant or not. Which in a sense it makes sense, right? Because anyone can use a lightsaber, even a non-Force user can use a lightsaber. Um, but in this context here, that doesn't seem to make a whole lot of sense. So you can actually, if it is appropriate, now we can say, okay, the first thing is we need to establish that we're only interested in whether a Jedi is Sith tolerant or not. Okay. So you can either change this rule, or you can make a new rule. You can basically say, Jedi is Sith tolerant. So now you have an extra restriction. So now you basically will say, is a Jedi X? So don't even bother if somebody is not a Jedi. Okay, we need somebody to be a Jedi to even consider whether that X is Sith tolerant or not. Now we are talking about something that makes more sense, because now we have a kind of restriction that seems to be useful in this case. So now we can say, Jedi is Sith tall. Okay, another typo. Getting the L. Sith tolerant. Okay, and we can specify any atom. Okay, we can specify Anakin blue again. So it would just return with a false, because Anakin blue cannot satisfy is a Jedi. So it returns right away, because the first item, because X is bound already. The query itself is um, binding variable X to Anakin blue. So the Prolog engine in this case has no option. It cannot say, well, let me find something else that can be X and see what happens. Nope, it doesn't have a choice. So in this case, if I press Control Enter, it will simply return with a false value. Now, what if I change Anakin blue to someone who is known to be a Jedi, like Yoda? Okay, so in that case, Yoda is known to be Sith tolerant, because even though Yoda does disagree with Darth Sidious, there's no confirmation that Yoda disagrees with Darth Vader. Now, how do we make Yoda not Sith tolerant? We have to add one more disagreement. We have to add one more disagree with, because now we need to make sure that Yoda disagrees with every Sith there is in this universe. So we have to also add Yoda disagrees with Darth Vader. Okay, once we have this rule, Yoda should not be Sith tolerant anymore, because of all the Sith known in this universe, Yoda is known to disagree with all of them. So now we press the Enter key, Control Enter, and it returns a false. So are we doing okay so far? With the use of Prolog. This negation here is negating a quantified statement of using y, which is existentially quantified, and x is universally quantified, but nonetheless it is a negation on top of a statement. Any questions? All right. I'm just looking at the time here. We have about 5 more minutes, so I'm gonna start to talk about the mechanism. What is making this possible? Okay, what is the mechanism? Or kind of more like, what are the terms of those mechanisms? I think generally speaking, we have talked about the mechanism already. So the whole thing is about substitution. Section 4 of the notes is basically this part is not specific to Prolog, it is specific to predicate calculus. So we're going to examine what a rule in Prolog means. We're going to revisit is a proper Jedi, and in this case, is a proper Jedi is we have seen this already, just not expressed in this particular way. So x is appearing on the left hand side, and that's why it is universally quantified, and it is just an element of u. And remember, u is representing the entire universe. The universe is a set of all of the atoms, and an atom is a lowercase thing that we mentioned somewhere within an entire program. So all of that stuff is kind of automatic. There's no declaration of, hey, this is an atom. Nope, anything that starts with a lowercase that is not a predicate is automatically an atom in this entire universe. Now, y as a variable is appearing only on the right hand side but not the left hand side, so it is existentially quantified, but it also has to be an element of u, the universe. So now we have the right hand side of the rule being the uh, precedent of a implication, and then we have the left hand side of the predicate or the rule being used as the consequent of an implication, and that's why it reads kind of backwards. But that's basically what that rule is specifying. Okay, that rule is specifying this whole thing here. And this is really the difference between propositional calculus versus predicate calculus, because propositional calculus cannot handle quantification, cannot have variables, cannot handle quantification, but predicate calculus can. So that means whatever you can express in propositional logic can easily be expressed in predicate calculus, but not the other way around. And predicate calculus is more general, it's more useful compared to propositional calculus. I have lost track of my Discord screen. Alright, so let me check out the text messages. Right, so according to the logic that we have specified in Swish, in order to be called Sith tolerant, you only have to find the lack of evidence of disagreeing with at least one Sith. That would make someone Sith tolerant. In order not to be Sith tolerant, there has to be evidence, or there has to be facts confirming that a thing, a particular atom, disagree with all Sith that is known in the universe. So is that okay? Because what we have here is the lack or the negation of an evidence. So the negation of an existential evidence is a universal of the reverse. It kind of goes back to when we talked about quantification. The negation of an existential quantification is the universal quantification, but with the predicate itself negated. But in the case of prologue, there's no way to confirm the negation of a fact, but you can say the lack of a fact. So that's why we can look for the lack of a fact instead of confirming the negation of a fact, because there's no way to confirm the negation of a fact. We can only confirm the absence of a fact. So anything that is absent is automatically false, basically. All right. Can I explain that again, but using Yoda? I'm not sure what that means, but let's go ahead and check this out. Okay, so let's check out this particular predicate first. Okay, so according to this predicate, in order for X to be a Jedi that is Sith tolerant, X has to be a Jedi first. So so is a Jedi X is going to go to all the facts. Well, it actually doesn't even care whether these are facts or not, but it will go through these things one by one until it finds a way to confirm is a Jedi. So the first one it's going to find is Luke Skywalker. So it will come back and say, okay, I have found someone who's a Jedi, and that turns out to be Luke Skywalker. And then it will take that, okay, take X being Luke Skywalker, and then say, is Luke Skywalker Sith tolerant? and it will go here, and then it will first try to find a Sith first. Now this is existentially quantified because y is not on the left hand side, so y is going to be existentially quantified, which means we only have to be able to find one y to satisfy everything here in order for this whole thing to work. So it's going to find a Sith, and the first Sith it is going to encounter is going to be Darth Vader. So now we know what is X. X is Luke Skywalker. Y is Darth Vader, and it would try to basically say, can we find any evidence that X, which is Luke Skywalker, disagree with Y, which is Darth Vader? And the answer is no, because we only have two facts related to disagree with, and neither is confirming that Luke is disagreeing with Darth Vader. So the lack of this particular, the fact that we cannot confirm this, and then we have a negation, will basically turn this entire thing to true, and that means Luke Skywalker is going to be known as Sith Tolerant. Then it's going to move on again, and look at the next thing. So if we want to look into Yoda, okay, specifically when we have a query like this, with Yoda already specified here, then we are looking for the first thing we look for is X being a Jedi, but X is already bound to Yoda, so we are just confirming that Yoda is a Jedi. And that is confirmed by just a fact. Okay, it's not confirmed by a rule, but it is a fact that Yoda is a Jedi. And then after that, it will continue to Sith Tolerant, but X is already known as Yoda at that point. So we get to Sith Tolerant with X being Yoda, and then it will find a Sith. Okay, the first Sith is going to find is going to be the first Sith is going to find is, oh, let me see, go back here, Darth Vader. And right, so now it will try to see if it finds evidence that Yoda disagrees with Darth Vader. And that is actually true because we have here this rule on line 40 confirming that. So once we confirm that, then the negation will turn it into false, and then it will go back here. Okay, if this is false, then it's going to go back and say, can we find another Sith? And it will go ahead and find another Sith, and this time we'll find Darth Sidious. So Darth Sidious will become Y, and then we'll try to confirm, okay, can we find that Yoda disagrees with Darth Sidious? And yes, we find that too. And then this negation is going to turn this part to false, so it's false again, and then we'll come back here and say, can we find yet another Sith? Can we find a Sith that Yoda is not known to disagree with? And the answer is no. We have already exhausted all the Sith that we can find. So that means the confirmation Sith Tolerant is now false. So if this is false, then it will try to backtrack here. But since Yoda is already bound to X, there are no alternatives to look into. So that means at this point we have a conclusion that Yoda is not Sith Tolerant, because this is returning as false, and there are no alternative that we can go here to say, can we find someone else? Alright, so I'm looking at the text channel. Can you explain that again but using Yoda? Okay, to disprove a negative is to prove a positive. Well, the negation, so I think the question is is basically surrounding the negation used here. So this negation is saying, the entire thing, okay, this entire thing is going to return true when we cannot find, when we cannot confirm this. If this cannot be confirmed, then the entire thing, is going to be considered true, and that's what the negation is trying to do. You are Sith tolerant as long as there's at least one Sith that you are not known to disagree with. Yes, I know it's a double negative, but in this case, the double negation is required because the first negation is not known to, which means there does not exist. And then the second one is from disagree with, because that's what the predicate is specifying. Now the easier way is to confirm agree with, right? Because if you say, well, we'll only express agree with, in other words, we'll have a white list instead of a black list. So it depends on the frequency. Okay, do you want to specify disagree with, or do you want to specify agree with? If most people are agreeable with other people, then you want to specify the disagree with, because then you don't have a whole bunch of stuff to specify. On the other hand, if most people are disagreeable with other people, then you want to specify agree with, because it will be a shorter list. So that's kind of a trade-off based on which one it makes more sense depending on the frequency. Um, the way to define Sithness is the confirmation up here. So the way we know Darth Vader is a Sith is because there's a fact stating that Darth Vader is a Sith. And the same way with Darth Sidious is there's a fact specifying that Darth Sidious is a Sith. So that should answer Wade's question. All right, today's pretty cool. Yeah, we are running out of time, so I will let you guys go so that you guys can help prepare for the Thanksgiving meal or whatever you guys do, on Thanksgiving Day. All right. Well, thank you for showing up today. It was kind of fun today. I think. I hope you guys find it as fun as I did, because I've known your prologue for a while already, and yet it's still quite a lot of fun. Every time I play with it. So I hope you guys find it a little bit interesting too. Um. All right. Cool. Yeah. You guys have a nice Thanksgiving too. I'll see you guys on Monday, and hopefully most people would have recovered from the food coma as a result of the big meal that some people have on Thanksgiving. I'll be driving a lot, so it's not going to be that much fun. Alrighty, so I'll see you guys on Monday. Have a good day, and yep. All right, I'm gonna stop the screen share and the stream